Hey guys, next lesson here we'll continue looking at logarithms, and we're going to talk about some properties of logarithms here in this video. So the properties of logarithms are actually going to stem from your properties of exponents, so I want to take some time to review those as we talk about three main properties today. The first property we'll talk about is the product property of logs, and so I want you to think back to your product property of exponents. So think back to if I have something like this, let's say b to the m power times b to the n power. You know, if you take the product of two powers that have the same base, you keep that base and then you add the exponent. So that would be b to the m plus n power. Well, the product property of logs is somewhat similar. If I take the log base b of a product, let's say the product m times n, then that's going to be equal to the sum of the log base b of m plus the log base b of n. Okay, so the product of log base b of m times n would be equal to the sum of the two separate logs, log base b of m plus log base b of n. Okay, so very similar to the exponent property we have up here that says you add the exponent. Same thing down here. When you get the log of a product, you add the separate logs. Okay, quotient property is going to look pretty similar as well. So if you remember, quotient property for exponents says if I'm taking two powers, same base, and I'm dividing, so b to the m divided by b to the n power, that's when I subtract my exponents. So that would be the same as b to the m minus n power. Well, same thing works for logs. So if I'm taking the log base b of a quotient, we'll say m over n, then that's going to be equal to the difference of log base b of m minus log base b of n. Okay, so again, they're very similar to your exponent property with quotients. Last property I want to talk about is your power property, and this property actually stems from your power property with exponents. So lastly, if we have b to the m power and we want to take that to the n power, we know that the rule there says that I multiply the exponents. So that would be the same thing as b to the m times n power. Well, when you have a logarithm, so log base b of a power, we'll say m to the n power, this property says that I take the product of the exponent times the log. So really that would be the same thing as the power, in this case n, times the logarithm log base b of m. Okay, so these right here are the three different properties that I want you to be familiar with logs: product property, quotient property, and power property. And now we're going to practice using these three properties in each of these examples below. So examples 1 through 4, what I'm going to be doing here is I'm going to be writing each of these expressions as a single logarithm. This is also known as condensing logarithmic expressions. Okay, so when you're condensing, you want to make sure that your expression only has the word log once, basically. So number 1, I have log base 5 of 3 plus log base 5 of 7. Well, anytime you see addition of logs, you know that is probably going to be dealing with your product property. Product property says anytime I am adding two logs with the same base, that is equivalent to taking a single log, same base, and multiplying what is called the arguments. The arguments, and I meant to mention this in the last video and forgot, are simply the m value and the n value. So when we're dealing with logs, these numbers here are what are called the arguments. Okay, argument is what that says. So log base 5 of 3 plus log base 5 of 7 would be equivalent to log base 5 of 3 times 7, which is the same as log base 5 of 21. Okay, number 2, we have log base 3 of 8 minus log base 3 of 5. Anytime I see subtraction, I know that's probably going to deal with my quotient property, which says that if I'm subtracting 2 logs, same base, I can make that a single log by taking the arguments and dividing them. So this would be equivalent to log base 3 of 8 divided by 5. And that's just going to be log base 3 of 8/5. That's all we can do with that one there. Number 3, I have log base 4 of 5x. And this one's actually a typo in your notes. I want you to make this a plus sign. So this should say plus log base 4 of 3x. Well, addition, again, that's going to involve your product property. So this one would be log base 4 of 5x times 3x. Multiply the arguments there, you get 15x squared. So this one becomes log base 4 of 15x squared. Then finally, number 4, we have 2 times log base 4 of 6 minus log base 4 of 9. Okay, 2 log base 4 of 6, first of all, I can rewrite that by using my power property. So any number that you're taking times the log can become the exponent on the argument. Okay, so I can rewrite 2 log base 4 of 6 as log base 4 of 6 squared. Okay, log base 4 of 6 squared, and then we're still subtracting log base 4 of 9. From that would become log base 4 of 36 minus log base 4 of 9. And then from there, to write this as a single log, I can use my quotient property. So I can do log base 4 of 36 over 9, which becomes simply log base 4 of 4. Okay, now, this problem, unlike 1, 2, and 3, I am not going to leave as log base 4 of 4, because this is one where I actually know what the log base 4 of 4 is. Remember, I told you there were a couple logs you had to memorize. Log base 4 of 4 is one of them. We know that this is going to be equivalent to 1. Anytime your base and your argument match each other, we know the answer is going to be 1, because, again, 4 to the first power is equal to 4. So anytime you can easily simplify the log at the end, I want you to go ahead and do that. So in this case, your simplified answer would just be 1. Okay, 5 through 8, we're just going to do the opposite of what we did on 1 through 4. We're going to, in these problems, expand each logarithm. So starting with number 5 here, we have the single logarithm log base 12 of x to the 4th. And in order to expand this, I don't want to have any powers remaining in my argument. Okay, no powers in my argument. So your argument shouldn't have any exponents. To get rid of that exponent there, I'm going to use my power property, which says I can take this exponent 4, and I can multiply it by the logarithm base 12 of x. Okay, so this becomes 4 log base 12 of x when I expand this log. Okay, number 6, I have log base 7 of 2x to the 6th. Be careful on this one. I can't just take the 6 out front like I did with number 5, because my argument in this case is a product, and the 2 is not being taken to the 6th power. Okay, 2x to the 6th power is 2 to the first x to the 6th. So in order to expand this log, the first thing I need to do is I need to actually separate my products by using the product property, which says I can write this as a sum. So this would become log base 7 of 2 plus log base 7 x to the 6th. Okay, so that would be my first step in this one. Now that I've done this, then on this second logarithm, I can take that exponent 6 and I can move it out to the front. So it would become 6 log base 7 of x. Okay, and then over here we still have our log base 7 of 2. So final answer for that one, log base 7 of 2 plus 6 log base 7 of x. Number 7, we have log base 2 of 4x cubed divided by y. So I have a quotient on this one. First thing I can do is I can split up that quotient using my quotient property. So that would become log base 2 of 4x cubed minus log base 2 of y. Okay, now this first logarithm here I can do the same way as I did number 6. I need to split it up first because it's a product. So that would become log base 2 of 4 plus log base 2 of x cubed. And then at the end we're going to be subtracting log base 2 of y. Okay, lastly, I can go ahead and my middle part here, use my power property, move this 3 out front. So it becomes plus 3 log base 2 of x. The other thing I can do is log base 2 of 4. I can simplify that because I know what the log base 2 of 4 is. 2 to the second power is 4. So log base 2 of 4 is simply 2. So we have 2 plus 3 log base 2 of x. And then at the end we still have our minus log base 2 of y. And that would be this logarithm expanded as much as possible. So again, no exponents in your arguments, okay? No products or quotients in your arguments either, okay? Every argument is a single variable or a single number. Okay, finally number 8, we have log, this would be base 10 of x squared times y to the negative first times radical z. So because this is a product, we're going to use the product property and make this a sum of logs. So this is going to be log base 10 of x squared plus log base 10 of y to the negative first plus log base 10 of radical z. Okay, the next thing I can do is use my product property. This 2 can come out front, as can this negative 1. So this would become 2 log base 10 of x minus log base 10 of y. And then radical z, I know I can rewrite as with an exponent. Radical z is the same thing as z to the 1/2, so this becomes log base 10 of z to the 1/2. From there, I can use my product property again, and I can take this 1/2 out front here, and so this becomes plus 1/2 log base 10 of z. So your final answer, you have 2 log base 10 of x minus log base 10 of y plus 1/2 log base 10 of z. Okay, so that's expanding logarithms using your properties. There's one other thing that I'd like to talk about in this lesson, and that is what is called your change of base formula. Okay, so your change of base formula says this. For any positive numbers m, b, and c, then as long as b and c are not equal to 1, the following is true. Log base b of m will always be equal to the log base c of m divided by the log base c of b. Okay? What this formula basically says is you can evaluate any logarithm, no matter the base and no matter the argument, by choosing another base, in this case c, and doing the log of the argument divided by the log of the original base, b. Okay, and the reason this is useful is because when I talked about in the last video how logs work on your scientific calculators, okay, your scientific calculators are only set up in base 10. This formula allows you to evaluate a log of any base, let's say base 12, by converting the logarithm to two other logs, both in base 10 and doing some dividing. Okay, so this formula is useful for any time you have a scientific calculator that only does base 10, evaluating logs that are not base 10. Again, it's called the change of base formula. We're going to practice it down here below. So, number 9, I have log base 81 of 27. In order to use the change of base formula on this, I'm going to convert this to two different logs, both in base 10, or the common log. And what I'm going to do is I'm going to take log base 10 of my argument, which is 27, divided by log base 10 of my original base, which was 81. So it's going to be log base 10 of 27 divided by log base 10 of 81, and that comes out to be actually exactly 0.75. If you think about that, that makes sense. 0.75 is the same thing as 3/4, and well, 81 to the 3/4 power would be the same thing as the 4th root of 81 cubed. We should know by now that the 4th root of 81 is 3, and 3 cubed would give us 27. Okay, the original argument. Okay, so that checks out if you think about this using the definition of a logarithm. Same way up here using the change of base formula. Okay. Number 10, we have log base 5 of 36. So in order to do this one you'll have to do on a calculator. You can do log base 10 of 36 divided by log base 10 of 5. If you do that on a calculator, you get approximately 2.23. Okay, 2.23. Number 11, log base 8 of 32. We're going to do log base 10 of 32 divided by log base 10 of 8. That would come out to be approximately 1.67 on a calculator. And then finally, number 12, log base 4 of 18 would be log base 10 of 18 divided by log base 10 of 4. And that would come out to be approximately 2.08. Okay, so that's a useful formula to know when you're dealing with scientific calculators. You're going to find that your graphing calculators are actually set up to do any base, and if you haven't figured that out yet, we'll talk about how you can use that. But again, you're going to need to know this formula in case you are in a situation where you don't have your graphing calculator, and that allows you to evaluate any logarithm no matter the base. Okay, as usual, any questions over this, be sure to jot those down. We'll talk about those in class next time I see you. Until then, have a nice day. You're all wonderful people.